This is a video on solving systems of equations by graphing. So a system of equation is just two equations, system meaning more than one, and two different variables. So I have to solve for x and y at the same time. This is kind of tricky to solve for two unknowns at the same time. So what we're going to do this is by graphing. So I'm going to set these up and I'll explain what the solution is. So first I'm going to take this equation over here and I'm going to graph it. So to make my life easier, I'm going to put it into slope-intercept form, or y equals mx plus b. I kind of like to put a box around it because I'm going to have a lot of equations up here. I kind of want to draw my eye back to what I'm going to use. I'm going to do the same thing with this one. Divide by -1. And I get y equals x minus 1. Alright, so here's the two that I'm going to use. So the definition of a solution to a system, the answer that I'm trying to get here, is basically all I'm trying to do is find the point at which the lines cross. That's all I need. Just find the point at which the lines cross. That's all I'm trying to do. So I'm going to graph this one. You have to be really precise here, because if you're not real careful and you draw your lines kind of crooked, they're not going to cross at the right place. So this one has a b of 3, 1, 2, 3. And I'm going to go, it has a slope of -1, so I'm going to go down 1 over 1. I'm just going to put a couple on there. Okay. This one crosses at -1. This one goes up 1 over 1. Okay. So now I'm going to draw these two lines. So here's the first one. Okay. Here's the second one. Okay. So my answer is simply where they cross. So I go look and see they cross at the coordinate point 2, +1. And that is my answer. I can also think of it x equals 2 and y equals 1. Alright. That's all I need to do. So let's do a few more of these. So I'm going to solve both. I'm going to start with this one. It looks a little easier to do first. I'm going to solve for y. Okay, so there's one equation that I'm going to use. I'm going to bring this one over here to give myself some room to work. And I'm going to subtract 5 to both sides. These are not like terms, so this is what I get. Divide everything by -1. And I get, I'm going to switch this around. So I'm going to put the y right here, just so it looks a little more like I'm used to. Okay. And then I'm going to graph these. Okay. So when looking at this, I'm going to graph this first one. And it's 1, 2, 3, 4, 5. I'm going to go down 3, 1, 2, 3 over 1. And then I'm going to come here and hopefully you'll realize, hey, you know what? This is actually the same line. So I'm just going to kind of put two sets of arrows on it to show that I graphed two lines, all right, on the same actual line. So now in this case, the solution is the point at which they cross. Well, these actually cross everywhere, okay? These cross everywhere, so this has an infinite amount of solutions. There's not just one point like I did in the previous example. This would be infinitely many points. Okay. All right, let's graph two more. So looking at this one's already ready to graph. I'll just graph that. It's 1, 2, 3, 4. And remember the x equals, it's really contrary to what you think, but those go up or down. They all have the same x value, and that puts points on top of each other, making a vertical line. And this one here, I'll solve for y. So that equals 2x plus 1 divided by 3. Okay. And we go right here. Okay. So now looking at this one, I got a fraction. It's not the end of the world here, but so I'm gonna start from 1/3. Okay, so that's 33%. So that's about right here. I'm going to go up 1, 2, 1, 2, 3 spaces. Okay. And if you look at it, a little bit hard to tell, but I crossed at the corner point 1, 2, 3, 4, 1, 2, 3. So my answer is 4/3 in the answer. So I could think of it as the x is 4 and the y is 3. Okay. Last example here. For this one, I'm going to graph it a little bit. I'm going to graph by x and y intercepts. So I'm going to take the x-intercepts and the y-intercepts. I'm going to take this first one here, so that's when the y is 0. And this one is when the x is 0. So pretty simple to do. So for this first line, which I did right here, but x-intercept is 4. 1, 2, 3, and 4. The y-intercept is also 4. 1, 2, 3, and 4. Okay. And then I'm going to do the same here for this one, kind of coming down here. And I'm going to get the x-intercept and the y-intercept. So I make the y 0, so x equals -4, and make the x equal. Okay. So that's 1, 2, 3, 4, 1, 2, 3, and 4. Okay. So now I'm going to draw these two lines. And if you remember, I'm trying to find the spot in which they cross, and by what I have here, it looks like they're not. They look parallel. Well, there's only way to find that out, and I can do that by checking their slopes and seeing if they're the same. So I'm going to take this equation right here. I'm going to take the other one right here. I'm going to solve for y and get them in the slope-intercept form. And if you look at it, you go, hey, you know what? They both have the same slope. The m is -1/1 and -1/1. So they're parallel. So these ones don't cross. So this is no solution.